This is Chapter 5, Section 1, Part 2. So the problem is the formulas are in years, right? So if you get months involved, you have to do a little bit of a conversion, right? Because if I go back here, you'll notice it says time in years, right? Okay. Well, let's set this up here. So 5 months, right? And we'll do a times. And then we'll set up a ratio, all right? Because this is 1 year is to 12 months, right? That's the conversion ratio, so the months and the months will cancel and leave you with some number of years. So you can get a decimal value here, but I would not recommend that because of the fact it might not work out nicely. It might be a one that keeps going on forever. So what I suggest doing is just doing 5 over 12 years. I recommend that is what you should do, right? So format color blue, and that is our years we would use in the formula essentially, because the formulas ask for years, right? So that's less than 1 year. But what if it was more than 1 year? Would that really make a difference? I mean, I guess. So let's do the same thing, right? So we're going to do 40 months, right? And then we're going to do times a ratio, which is 1 year to 12 months. Okay. So format color blue. So that's going to give me the months will cancel. So that's 40 over 12 years. That's more than fine. Yes, your grade school teacher said you had to simplify fractions. That's not actually true. That's more than fine they put in the computer. If you want to, you can simplify it, right, and get 10 over 3 years. But when you use the formula for interest and loans, it doesn't matter whether you use this one or this one. I would say don't waste your time. Just give the original, because that's more than fine. And that's what we're going to do for ours, essentially. Okay? All right, so we want to know the interest paid on a maturity of 70-month loan. Okay, so let's go back and steal the formula from the previous section for the interest, right? So I'm just going to steal this one here. Okay. And we'll delete all our stuff here. Delete this, and delete this. Okay, so the principal on the loan is $8,600 times the rate. Well, the rate here is 5.34%, which equals a ratio of 5.34 divided by 100, which is 0.0534, correct? Okay, so that converts that. So 75. I'm sorry, it's 3/4. That's 75. I'm sorry, I don't know why I did that. My brain's not working today here. 3/4 is 75. Okay, so 0.0575. Right? If you have trouble with that, you can always use the spreadsheet, right? Because it's 5 plus 3/4, right? Because that's what a mixed numeral means, right? You look back at your notes. 5 and 3/4 means 5 plus 3/4, which is 5.75, right? Okay. All right. So the next thing we need is the times, right? So we got P times R times T, but T is in years, correct? So we have 70 months times, and we do a ratio. 1 year is to 12 months. And I get a ratio of 70 over 12 years, right? So I'm going to put the ratio up here, right? Can I simplify 70 over 12? Sure. Do I need to? You absolutely do not need to do that, right? So we just need to plug this into our spreadsheet to get our interest, right? So I'm going to go to our spreadsheet and do I equals, okay, and then shift that to the right. Okay, so it was equals to equate, right? Because if you don't put the equals, it won't equate. It'll just print whatever you type. 5,000 times the 0.0575, right? Is that the correct one? Let's double check. 575. Then we have the 70 twelfths, right? So times, parentheses, 70 divided by 12, right? So we have the principal, the interest, and the number of years, which is a fraction, because not everything is a whole number of years. It might be, 6 years and 2 months, who knows, you know what I'm saying? Okay, so we get that amount of money there. Okay. Did I... Wait a minute. Was it 5,000? It was 8,600. I am sorry. It was 8,600. Okay. I got to pay attention to what I'm doing. 5,000 was the previous problem. This problem was $8,600. Okay. So that's the amount of money we get, which is not perfect. So I'll tell you the truth, though. They probably always round up. So I'm going to go to this. Oh boy, I'm clicking around here like a crazy man. Okay, so I'm going to put a $2884.59. And you can make this box bigger too to get more decimals. But they usually just round up on the interest, to be honest with you. Okay, so it never works out nicely, but I would just round up because that's what the bank does. Okay. All right, so it says determine the interest paid and the maturity value. Oh, so we need that too, right? So if I think about the maturity value, right? The maturity value is the A amount, isn't it? Right? Which would be the 8,600 plus this amount here, wouldn't it? Correct? So that would give me, if I go to my spreadsheet, A equals, and I'm going to shift that to the right. So I'm going to do the equals 8,600 plus, and then I'm going to click on this box right here to add for me, right? And that gives me 11,484, 11,484.59. We can make this blue, format color blue. Okay, and we can do the formula also, right? So A equals, right? And we can copy the formula from before. So let's do this: format color blue. Let's go get the formula from the previous page, right? This is the maturity value stuff right here, right? I'm going to steal the formula for maturity value, and then go down here and put that into there, right? So that's 8,600 parentheses 1 plus the rate, which is 0.0575, times the time period, right? So this should give us the same answer, correct? Because principal plus interest is the maturity value, or the amount in the end, right? Which is also this formula. So we should get the same answer either way. Okay? All right, so let's go to our spreadsheet now and put that in. So we should get the same answer. So 8,600 with the equals also equates times parentheses 1 plus the 0.0575 times parentheses, what was the fraction? The fraction was 70 over 12. 70 divided by 12. Close paren, right? So that's the formula. So this should match the one we did before, because again, it's principal plus interest, right? Which we did separately in this one. This one we just did the formula. Same answer. Okay? So it does not matter. You get the same answer either way. Okay? And again, in both cases, you're just rounding up a penny because they usually take that extra penny for themselves, right? Okay. All right, let's go back to the document here. Okay. So you invest $4,500 into a CD. That's a certificate of deposit, right? It's kind of like a bank account, but you can't withdraw until the end of the period. You get more interest than normal, than a regular bank account. It earns 2.5% simple interest. That's the formula we're doing. How long will it take to double your investment, basically? Okay, so I'm going to steal this formula up here. That's the formula we want, right? And we'll paste this down here. Okay, and we'll work from here. Okay, so if we want to double our amount, that would be $9,000, correct? Because we're investing $4,500, so we double it would be $9,000. The initial investment is $4,500. Then we have 1 plus the rate, well, it's 2.5%, so that's 0.025, right? That's the 2.5%, times T. You're like, wait a minute. But it says how long. We don't know T, right? So we need to solve the equation here algebraically. So what I'm going to do is I'm going to take this equation and solve algebraically, which means the first thing I want to do is divide both sides by 4,500. You can also distribute the 4,500, but I think that would be more difficult, to be honest with you. Okay, so that's going to give me 2 on this side, and then that's going to leave me with this on the other side, because the 4,500 will cancel, right? So the next step is to subtract the 1 off, right? So that's what I'm going to do. So I'm going to subtract 1 from both sides. So I'm going to subtract 1 from that side, and I'm going to subtract 1 from that side. So that's going to leave me with 1 equals this, right? Because 2 minus 1 is 1, and then 1 minus 1 just goes away. So the last step is to get rid of this, which is a multiply, so I have to divide, don't I? So I'm going to take this, and I'm going to divide both sides by 0.025. Okay, so I'm going to get a t answer here, but I need to do this in the spreadsheet essentially, right? So 1 divided by that amount. So go to my spreadsheet. I'm going to do t equals, shift that to the right. Okay, I'm going to do the 1 divided by 0.025, right? Put the equals first so it equates, and I get 40. Okay, so this is 40 years. Okay, so the question we answered is, how long will it take to double my money? Okay, well, we still use this for not only loans, but for accounts too that generate money, so it goes both ways, right? So I start with 4,500. I want 9,000, so this t is what I want. So I got 40 years later. Okay, all right, that's the end of part 2.